So in today's lesson, we're going to be adding rational expressions with unlike denominators. So look at this, notice. The least common denominator must include all the factors from the original denominators. So that means you're going to have to factor your denominators first. So that you know what you're dealing with. You got to do that first, okay? So let's flash back to middle school for a moment. Let's look at this. When you had two different denominators, the way you found your least common denominator a lot of the times was just multiplying the two that you had, right? So then you had to go back and figure out, okay, I got to multiply this one by 2 over 2 to make that denominator 6. And the second part, I have to multiply by 3 over 3. And then when I did that, I would have a 2 plus 3. My denominators would both be 6 now, so I could just do 5 over 6, and there's where I finished. So we're going to do the same thing today. However, the denominators are going to be expressions, not just a number, and expressions with a variable. So look at your directions. It says simplify each expression, state any restrictions on the variables. So let's look at this. So notice the different denominators, x minus 3, x minus 2. So my least common denominator will be x minus 3 times x minus 2. And just like before, I need to go back to each one of these and figure out what I need to multiply by. Well, this one needs to be multiplied by x minus 2. This back one needs to be multiplied by x minus 3 for the denominators to match. And then you're going to be distributing. It's just distributing across each of these, okay? So we'll have 3x minus 6 plus 2x minus 6. So when I clean that up, I will have 5x minus 12 over x minus 3 times x minus 2. And then I make sure, can I reduce anything, GCF the top? None of that works on this one. But I do need to think about my restrictions. What is it that x cannot equal? Well, look at your denominator. Look at the factors. If I do these in my head, x minus 3 equals 0, what does that mean x cannot be? It cannot be a 3, and here it cannot be a 2. So I can list those out. So 3 and a 2. Let's try another one. Number 2, 2x minus 8 over x squared minus 16 plus 3 over x plus 4. So I need to factor the denominator here. The first one, they were already factored. This one's not factored. See how it's quadratic? Let's factor that. Hopefully you recognize this is a difference of squares. So x minus 4, x plus 4. So I'm going to rewrite it that way so that I can then see that this is really a difference of squares. And over here, this one is one part of it already, right? So my common denominator is going to be x minus 4, x plus 4. So then this first fraction is good to go. I don't need to multiply by anything but 1 over 1. You don't even have to write that. The back one I need to multiply by x minus 4. And let's see what happens when I distribute. Now the first one, obviously there's nothing to distribute, so I carry it over. So this will be a 2x minus 8 plus, now I distribute that 3x minus 12. And let's clean this up. So 2x plus 3x is 5x. Negative 8 minus 12 is negative 20 over x minus 4 times x plus 4. Now hopefully you can see that we can take a GCF out of that top one, right? Take a 5 out, and what's left is x minus 4. Now, there's something I can reduce, right? This x minus 4 goes away. So my answer will be the simplified expression of 5 over x plus 4. However, I need some restrictions. So even consider the ones that you crossed out. So think back before you reduce what was going on in the denominator. What can it not be? X cannot be a positive 4, and it cannot be a negative 4. So you can write it like that. X cannot equal plus or minus 4, but you need to have both the positive and the negative 4 included. One more. Let's look at number 3. 7 over x plus 4 plus 7 over x squared plus 7 plus 12. Let's factor this denominator first, okay? Two numbers that multiply to 12 but add to 7, hopefully you catch those as x plus 3, x plus 4. That means my common denominator, my least common denominator, will be x plus 4 times x plus 3. Now, what do we need to do to this first one? Well, we need an x plus 3, don't we? To make those denominators match. So I need to distribute the 7. So that will give me 7x plus 21 plus 7. Let's clean this up a little bit. 7x plus 28 when I add those. So I have x plus 4 times x plus 3. Always check to see if you can do a GCF, which we can on that numerator. If I take a 7 out, I'll have x plus 4 over x plus 4 times x plus 3. All right, now I can see that I can reduce that x plus 4 out. So my final answer will be 7 over x plus 3. But I need to go back and do my restrictions. Okay, before I canceled, what was it that would make this undefined? Well, if x was 4 or if x was negative 3, that would make the denominator 0. So we don't want those. We have to exclude them. All right, that's how we do it today. That's how we get our denominators the same. Let me know what questions you have when you come to class. Good luck.